you doing? It's Mr. Do the Math, and today we're going to talk about adding and subtracting polynomials. All right. In order for us to know what a polynomial is, we need to know what separates them, right? Or what separates terms. So polynomials are math sentences or math expressions that have terms in them, right? A term is a piece of math connected by plus or minus signs, right? So a term is separated by plus or minus signs, right? That's how you know if you have a term or you know the number of terms that you have, right? So classifying polynomials depends on how many of these we have, right? So let's talk about that. God bless you. All right. A one-term expression is known as a monomial, right? So one term, monomial. I think we talked about this before. Monomial. Two terms. What's the prefix for two? Binomial. So if we have a binomial, that means we have one plus or minus sign. All right. One term we have 0 plus or minus signs. Right. You just have variables and numbers present. Right. Three terms. What's the prefix for three? Tri. Three terms, trinomial. All right, that means you have 2 plus or minus signs. All right, and then an expression with 4 or more terms is known as a polynomial. Right, 4 or more polynomial. All right, so it's a greater than or equal to 4 terms. That's a polynomial. Okay. So again, terms are variables and numbers that are separated by plus and minus signs. All right. So a polynomial with one type of variable. When you have a polynomial with one type of variable, you need to write it in standard form. All right. Standard form. Standard form is when a polynomial has one variable, right, and their exponents have to be written in descending order. Okay. So in order for it to be in standard form, you have the same variable, and the equation has to be written in descending order of the variable's exponent. So if 3 is the biggest exponent, the next term has to have 2, the next term has to have 1, and then the next term has to be a constant. Okay? So this is what I'm saying. If this was 3x to the third plus 4x squared plus 5x plus 5. This is standard form. 3, 2, 1 is always invisible, and then x to the 0 power is 1, right? So this is 3, 2, 1, 0, right? So this is considered standard form. Okay, so whenever you have an expression and they say write it in standard form, this is what we're expecting. This is what we're asking for. You got me, Kennedy? Okay, so the degree of the polynomial, right? In Algebra 2, we represent the degree of the polynomial different, but here we'll say just the degree. The degree of the polynomial is the biggest exponent present. God bless you. The biggest exponent. The degree of the polynomial is the biggest exponent. Okay? So in this particular problem here, what's the largest exponent?
3.
3. 3. So it's a third degree polynomial. All right? If you're looking at this example here, right? So the degree of the polynomial is the biggest exponent present. Whatever the largest exponent is, that's the degree of the polynomial. All right? Leading coefficient Leading coefficient is the coefficient or the big number. It's the big number. Yes, sir.
Can I borrow Montez and Antoine?
Neither are here. The biggest number is the biggest. It's not. Threw me off. All right. So the leading coefficient is the big number, right? That's the bottom. Or the coefficient connected to the largest exponent. So the leading coefficient is the coefficient of the degree of the polynomial. So in this case, if this is the third, 3 is the biggest exponent, right? Mm-hmm. So the big number, or the coefficient to him, is the leading coefficient. So the leading coefficient is this 3 here. All right. So the coefficient of the term with the largest exponent. All right. Remember, the coefficient is the big number. Coefficient is big number, right? Connected to the largest exponent. Everybody good with that? I don't know yet. We don't see them. Here we go. Let's look at this example here. It says, write the polynomial in standard form. Identify the degree, the leading coefficient of the polynomial. Then we want to classify it by its number of terms. So we're about to do this, but you can start ahead to see if you understand. All right. So number 1 looks like this. Says 5x minus 2 minus 7 x to the third plus x squared. Okay? So what we needed to do first is write it in standard form. That's by descending order of the exponents. All right? What's the largest exponent you see in this particular problem? 3. Right? So this will go first. So it'll be 7x to the third, negative 7x to the third. Is there an x squared term? Mm-hmm. Is there an x squared term? Yes or no? Yes. All right. Plus x squared. Here's a x term. Plus 5x minus 2. So this is standard form. All right. This is standard form. That's the first part. The next thing we wanted to know is the degree of the polynomial. What is the largest exponent present? What's the largest exponent? 3. So it's a third degree polynomial. All right. And then they said the leading coefficient. Leading coefficient is what? What's the coefficient connected to x to the third?
Negative 7.
Negative 7 is the leading coefficient. Right? And then how many terms? Classify. Classify. All right, how many terms do we see here? 4? Let's see. 1, 2, 3, 4. So it is a polynomial. Polynomial with 4 terms. All right, so standard form, 3, 2, 1, 0, right? In order, the degree of the polynomial is third degree. The leading coefficient is negative 7, right? And you got 4 terms. It's a 4-term polynomial, okay? Now, let's look at number 2. Number 2 says 4 plus x, all right? Put that in standard form. Is it in standard form here? Give me a head nod at least. Give me a head nod. Standard form? It is? No? I got some no's. I got some yeses. I got some no's. Standard form, yes or no? Yes?
No.
All right, those that say yes, why is it standard form? Those that say no, why is it not in standard form?
Ain't the x supposed to go first?
The x term has to go first. So it's x to the first power, right? So this should be x plus 4. That's standard form. Okay? What's the degree of the polynomial? What's the degree? First. When you see x, it's understood that there's a 1 here and there's a 1 here. Right? So it's the first degree polynomial. Leading coefficient is what?
1.
1 is the leading coefficient. Remember I said if it's x, it's going to be a 1 there and it's going to be a 1 there, right? And then classify. How many terms we got?
2.
So what's that?
Binomial.
Good. I feel like we talked about this in the last chapter. Binomials and stuff like that. Yeah, okay, cool. All right. Number 3. All right, number 3 right here. 8y to the 5th. Is that in standard form? Yeah, ain't no terms. All right. So that's in standard form. What's the degree of the polynomial? Say it louder. 5. 5th degree. All right. What's the leading coefficient?
8.
8. That's the number in front. All right. Classify. What class is this? How many terms you got?
1.
1. So monomial. All right. So monomial. All right. Number 4. That's the one I really wanted to see. Number 4. You got 4a to the 2nd plus 7 minus 5a. Write that in standard form. Write that in standard form. Write that in standard form. Yeah? All right. Let's talk about it. What would standard form be? Please, somebody tell me. Talk to me, please. Talk to me.
I can't raise my hand, but I'll do it.
All right, talk to me.
4a to the 2nd minus 5a plus 7.
Good. 4a squared minus 5a plus 7. Right? Did anybody have that? We had that? Good. What's the degree of the polynomial?
2nd.
2. Kennedy, what's the leading coefficient? Ask Marianne. Bentley, you got Retired, did you raise your hand? No? Huh? 4. Yeah. If this is the degree, this is the leading coefficient. You follow me, Kennedy? What'd I say? You didn't even look, you wasn't even looking at me. What's the coefficient? Huh? Alright. Classify. What's the classification of this polynomial? Okay, good. Trinomial. Good. So you won't see this type of stuff again until Algebra 2, right? Degree, leading coefficient, and standard form, which is fantastic. You got to see it now. All right. Now let's talk about adding and subtracting polynomials. Now, adding and subtracting polynomials is the same thing we did first semester, where we were combining like terms essentially. That's all we're doing. I think the biggest thing now is distributing like signs through. For instance, we'll warm up with let's go straight to number 6. Let's look at number 6 because that's the meat and potato look. Right? So we have 3y minus 4y squared plus 8 minus the quantity of 3 minus 7y plus y squared. Now, what we want to do is combine like terms. This minus sign says that we don't multiply. But this minus sign does say that we distribute this negative sign into every term in those parentheses. All right? So when you distribute just the minus sign, the signs change in here completely. So you got 3y minus 4y squared plus 8 minus 3 negative 1 times negative 7 plus 7y, negative 1 times positive y squared minus y squared. Okay? So now we've rewritten the problem after distributing the negative sign through. Bentley, you already worked this out? All right? So from here, we want to combine like terms. We got a y squared here. We got a y squared there. And then we have a y term, and then we have 2 whole numbers, 2 constants. So we're gonna subtract the circles together. So we're gonna add them together. Same sign, it's -4 and -1. Same sign, add and keep. So the answer is what?
Negative 5y.
Negative 5y squared. Then we have 3y, 7y. 3 plus 7
10.
plus 10y. And then 8 minus 3
5.
plus 5. Okay? So, we're going to add or subtract, and then we're going to classify. How many terms do we have present here?
3.
3. So what is it?
Try.
Trinomial. Good. Trinomial. That's it right there. So, these other problems kind of works the same way. Let's jump down to... All right, let's do we want to do 7 or 8? Look at 7 or 8, and then we're going to jump down to 9 or 10. 7 or 8, which one you want to do?
8.
8? All right, let's look at number 8. All right, let us erase this. Go to number 8. Let's work on number 8. You'll do 7 alone. Number 8 says 3 times the quantity of 5m plus 6 plus m times the quantity of 6m squared minus 4m plus 2. Look, this is all that we did last chapter, right? So the first thing we want to do is distribute. All right, Rataj? So you got to multiply 5m by 3, 15m. 3 times 6. What's 3 times 6? Not 15.
He said 18.
Okay, 18. All right, good. Then we have m times 6m squared. When we multiply variables, what do we do to the exponents? Add them. So that's 1 plus 2. So that's going to be 6m to the third. M times negative 4m. Negative 4m. 1 plus 1 to the second. And then m times 2, which would be 2m. Okay? So we distributed. The next thing we want to do is combine your like terms. What like terms do we have?
15 and 2.
15m and 2m. These are the only like terms present. 15 plus 2 is 17. So if we were to write this problem in standard form, which term would go first?
6m.
6m to the third. Good. What's next?
Negative 4.
Minus 4m squared plus 17m, 15 plus 2, and then plus 18. Okay? Now, very good. To review everything we learned so far, what's the degree of this polynomial?
Third.
3. What's the leading coefficient?
6.
6. And what's the classification? Polynomial. 4-term polynomial. Very good. All right. Cool. Very good. So I think we got it. The last part, we're dealing with expressions with more than one variable. Expressions with more than one variable. Okay? Now, when you have an expression with more than one variable, right? With more than one variable, you do the same thing. You still combine like terms, right? So, looking at number 9, we got 5x squared minus xy plus 4y squared plus x squared minus 5xy minus 3y squared. All right? There's legit no difference in how you operate. You just got some extra variables present. Okay? Because of this plus sign, nothing here changes. So let's just drop the parentheses. So you got 5x squared minus xy plus 4y squared plus x squared minus 5xy minus 3y squared. Okay? Now, we have this whole problem here. Now we're going to combine the like terms. All right, we see x squared. We got 1x squared here, and we got 1x squared here, right? So that's 5x squared plus x squared. What's that? 6x squared. We have negative xy minus 5xy.
Negative 6xy.
Y'all agree? Negative 6xy, because that's 1. Same sign, they're both negative. You add and keep the negative sign. Alright? Then we have, what kind of shape? We're going to have to draw like one of them. Alright, y squared, 4y squared minus 3y squared.
1y squared.
1y squared. So is it positive or negative?
Positive.
Why is it positive?
Because 4 is the bigger number.
So it'll be plus y squared. Okay? Plus y squared. So you put these in order, right? You got your terms like so. Okay? So essentially, this is adding and subtracting polynomials. But what we also did do is we identified what it looks for. The polynomial looks like in standard form, the degree of the polynomial, leading coefficient of the polynomial. And then we, of course, reviewed classifying polynomials. If you have any more questions, do you have any questions?
No.
How do you feel about it? Thumbs up, thumbs side, thumbs down.
Did you take any worksheets for chapter 7?
If you have any questions, comment below. Till next time, let's do the math out.